Hi there, welcome to my video. So in this series of videos, I will be teaching about the three-phase electrical system, which is a prominent and fundamental chapter to be learned in electrical engineering. So before we begin, I suggest you to jot down the notes and please revise time to time so that you can understand it much better. So before I begin, I would like to remind you, please leave any comments and questions in the comment sections. I will definitely respond to your questions. And if you are benefited from this video, definitely please leave a like and subscribe my channel, so it motivates me to create a better content in the future. So let's dive in. So what is three-phase system actually? Three-phase system is a power distribution system that uses three alternating power supply AC voltage that are three-phase shifted by 120 degrees respect to each other. I know it rather confusing to hear this way, right? It's okay, as we get along with it, you will get the concept. Okay, there are two types, of three-phase system widely used, which is three-phase star connection, or Y, also known as Y connection, as well as delta connection three-phase system. Okay, now let's look at this general schematic diagram. There's no such thing as this. I've just drawn this to give you a vivid understanding what this concept is about. First grasp the concept, later you can understand, you can just solve any sort of problems if it comes up. So first of all, we have to get along with the concept. So first of all, look at the parts there. There are three parts, A, B and C. A is the generator, B is the external load, and the B is only considered if any external load is present, otherwise we can ignore this part. C is load. So if you look at there, A and C is a compulsory, whereas B is an optional. If you look beneath, there's an arrow pointing from A towards C, which represent that direction of power is being delivered. Usually, generator, it's a typical electrical problem where the source delivers the energy and it's being received by the load, that whatever you are connected the load to. Okay, in this case, the load could be star or delta connected, or vice versa. The generator could be delta or star connected. So, in total, there are four combinations of generator and loads. Let's look through each one of them. Okay. In this video, I will just briefly go through four of it. Then later, I will go through each one of them and their syntax, how they are constructed, why they are constructed that way, and things to be considered when it is constructed in such manner. So let's look at the four types of connections: star-star, delta-star, star-delta, and also delta-delta. So let's look at the first type. Type 1. Here I've drawn the star-star connected three-phase system, or YY. It's the same way of saying it. Okay. So remember, we should only consider AC supply in the case of three-phase system. There's no DC three-phase system. Okay. So AC three-phase system. And I've zoomed in here so that you can look clearly. At the generator part, there are three ways to represent the supply load in the generator. If you look here, this is one way to represent the generator, where there's a circle, then it's like a wave like in the middle. It shows the AC supply, or I've drawn like a curly coil. This is not an inductor, this is a curled generator coil. Okay. On the B, it's just normal usual way of drawing supply, where we put the plus and minus symbol indicating the direction of the current flow. So on the left hand side is the generator, on the right hand side is the load. If you look here, we have drawn a resistor which shows the load for this line is resistor, whereas there is a box as well. This is also visual representation that shows a resistance in a load, whereas in this box it could be impedance. Combinations of resistance and reactance. Which reactance? Inductance or capacitance? Okay. Capacitive reactance or inductive reactance. It could be RL or RC as well. If we dissect it, if we look in further, we could see, let's say I could draw a resistor along with a capacitor. This thing could be represented as in a single box. So this is another way to represent an impedance in a three-phase system. This one is a Y-Y connection three-phase system, followed by delta-delta connected three-phase system. Another thing to consider is the nodes. If you look closely, the nodes here are A, B, C. So the A, capital A, represent the general generator part, uppercase letter for generator and lowercase for the load, where we can differentiate the alphabets so that we don't get confused. In the delta, the important things to be considered is the direction. We have to see A, B, C. A, B, C connected delta. The current flows from A, the voltage is from A to B. Means A should be labeled with positive and B is negative. And B is positive, C is negative, and C is positive, A is negative. How to know this? Later I will review back to make you understand why is it drawn in such way. There is the concept of sequence which will make you understand much better in this case. Okay, so for delta connected, we have to remember it always connected A to A, point A to point A of load, point A generator to point A of load, point B generator to point B of load, point C generator to point C of load. So that's the concept actually. If mentioned that balanced load, all the loads in the load side have the same value. So now let's look at the Y connection, Y delta connection. Means the generator is connected in Y and the load is connected in delta. Same goes for delta Y is just a mirror of the previous type 3, which is star delta, delta star, the same thing. Just the thing is that the delta is being generator now and star is being the load. So that's all for this video. So I will continue the further discussion in the upcoming video, and I recommend you to please go through each one of this video without skipping it so that you can understand the concept in depth. Okay, thank you for watching.